Hey guys, I am going to launch my object oriented programming course, and in this course, I'll give you a deep conceptual understanding of every topic in the OOPS, whether it is classes, object. We talk about four pillars of OOPS, that is encapsulation, abstraction, inheritance, polymorphism, and so let me tell you the syllabus of this. By the way, you will get the syllabus in the description as well. So, uh, first, we will cover the fundamental of OOPS. So, we will talk about what is the limitation of traditional programming approach. Okay, then we will try to understand how OOPS makes the programming and code more readable and more better. Okay, then we will talk about classes and object, what is new keyword, how to initialize an object, types of variables like instance variable, local variable, static variable. In Java we will see in depth, and what is JVM, how JVM execute your program, and then we will talk about constructor and its type, like default constructor, parameterized constructor, copy constructor. We will see in depth and in detail. Then I will talk about memory area, what is heap, stack, and memory area. And then we will see the glimpse of what is the role of garbage collection. Okay, then we'll talk about what is primitive and reference type, local variable, instance variable, wrapper class, typecasting, auto boxing, unboxing. Okay, then again, uh, then we will move to encapsulation. We will see in depth about encapsulation, then abstraction. Then we will talk about inheritance, and uh, then we will move to polymorphism. Most important topic in the interview point of view. Okay. Then we will talk about composition versus inheritance. In this, we will see what is has a relationship, what is tight coupling and loose coupling. Okay, we will see all of this, and at the end, you will we will practice at least 20 oops problem, like designing a banking application, library management system, and a booking application, and many more. So, and this course will be at least in two or three parts. So we will cover in two or three parts. Okay, because this is a lengthy course. Okay, so we will see. So let's start our very first lecture of object-oriented programming. So imagine a scenario. You are in class 10th, you are in class 10th, and your class strength is, let's say 100. Your class strength is 100, right? And so, uh, a- so a teacher, imagine a teacher has come and uh, pick and stand one student out of 100. So suppose a teacher will will stand up you. Now you have you have your unique roll number, right? You must have name, right? And let's say you have certain marks you have scored. Okay, so you have marks. Now, if this data, if these data you want to store, how you can store um, how you can store these data, right? So in a class there are hundreds of students. Now you can say that maybe I'll create data type for every 100 student, like this. like I'm doing this. Student 1 ID, let's say 01, then name may be in string. Student 1 name equals to, let's say, ABC. Okay. Now marks, let's say marks in float S1 marks equals to, let's say, 99.5. So for float you have to give f, small f. Okay. So you might do like this for student 1 ID 1 name and their marks. For student 2 you also create like this. Here you store the student 2 ID, student 2 name, and student 2 marks, right? And you'll create uh, like hundreds of these data types. Okay. One way to store these data is like this. You can see here. But is there any better approach to store this type of data? So you might have studies about arrays. So you say rather than doing like this, we can create an ID array. Yeah, that's a better approach for this. We'll create an ID array, and the size of array is 100 because we have 100 students in a class. Okay. Likewise, you can create a string array type name equals to new string. Yeah, and the size is also 100. Now, uh, for marks, you can also create a float array. Yeah, and sorry, float, and size is also 100, right? So you say that rather than creating uh, data type for each of the student, we can create an array and we can assign, right? We can assign, for example, you can say for index 0, student 1 ID, name, and marks will be stored. Okay. So because array indexing start from 0, so we are for 1, you can say student 2. For index 3, you can say student 3 ID, marks, and name will be stored. Okay. But have you noticed an issue in this approach also? Have you noticed that? So this approach is very hard to scale, right? And to manage indexing, you can say to manage the indexing of each student, this is hard to manage, right? And the major issue is that this is not secure. Anyone can access the information in that array. Okay. Anyone can access the ID of any student, name and marks of any student. So this approach is not secure as well, right? If you do, if you ever do C programming, so there is no concept of object-oriented programming in C programming. So you have to do like this if you uh, do in a C programming. Okay. But in Java, we have object-oriented programming, which makes our life easier. We will see it how it can, but for now, so imagine, let's say student. Okay, so rather than creating rather than creating a data type for each student, I will comment. So rather than doing like so rather than creating data type for each student, if there is a data type, let's say student. Now imagine student is a data type. Okay, so if there is a data type, let's say student, which contain our requirement, means now in this case what is our required data type? So our required data type is int, which store what? Which stores the ID, and another is string, which stores the name of a student, and float, which stores the marks of the student. Now imagine if there is a data type, let's say student, you can also write your girlfriend name. Okay, now imagine a data type. Here in this case, I'm imagining student which has int, string, float. So if in this data type, if there are all these data type inside this student, our life will be more easier, isn't it? So now let's say student stu1. See this, imagine this is a data type. I'll tell you now imagine this is a data type and we assign this data type to student 1. Okay, so we do not, now if this is the case, we do not have to manually create this data type again and again. Okay, again and again, we do not have to, but just we write student. Inside this student, all this data type will be created automatically. Isn't it easier approach? Okay, here comes the concept of classes. Here comes the concept of classes. Now, see, I haven't tell you the oops. What is oops yet? Okay, I will I will tell you slowly. Just for now, just go with the flow. Now, this student, this student, we can create a class of this student, and we can create a class of this student, and in this class we can define our required data type. We have created a class. Okay, and in this class all the required data type we can write, like this int. Let's say we need ID. Yeah, go for it. Let's say we need string name. Yeah, go for it. And now you can also have float marks. Yeah, go for it. No issue. So imagine this class as a data type which has ID, string, and float. Okay. Uh, in near future, if you want another data type, int, let's say age, you can store it. No issue. No issue with that. You can also store. Okay. So Now, how you can initialize this now? So here, this is a data type we assign to student one. Now we have to create the object of student one. How you can create and what is an object, what is in class, I will yet to explain. So new student. So what I'm writing here, what I, now what I'm doing here. So I have written student stu1 or student one equals to new student. Wait, I think I have, yeah, now it's fine. So I've, so this is a main class. Outside this class, I've created another class named student, and it contain int, string, float. For now, I've commented the age. Yeah. So what this line means? What this line means? See, student one as you are, let's say you are the student one, okay, and if if your teacher point out and stands you, what I mean, so you are a student one, okay, and if I ask the student one, you must contain, you must have your roll number, name, and your marks, okay. Inside student one, you are one object, okay, you are one object of student class, of student class. You are one object of what? Student class. And in this student class, what are the variables defined, or you can say field is defined. So student must have id, name, and marks field, okay. So if this is a student one object of class student, then student one must have these field, okay. Now you can also create another student, let's say stu2, okay, new student, right? So if I point out to student 2, then student 2 must contain, if student 2 is a, if student 2 is a part of this class, then student 2 must have these field, okay. Now let's talk about what is this new student, why I'm writing this, why I have written this new student. So this new student creates an object. This new student creates an object, okay. I will tell you in detail. Now I've also written the notes for you guys. So let me open this. Whatever I have teach, I have written in these notes as well. So let's start with oops. So what is oops? Oops is a programming technique where we structured our code around classes and object. Here, what I have done, I've create a class. So in in first or second scenario, we don't have any class. We have to create a data type for every student ID, name, or rather we can store it in an array. But oops is a technique. Oops is a technique where we structured our code around classes and object. Here we structured our code in classes. In classes, we have create a class student and we create object of every student. Okay, so it is a technique. It is nothing but a technique. Okay, you can do you can do the same thing without class and object, but oops make our life easier by providing. See, the oops follow do not repeat yourself concept means here in this case when I am writing like this, what I am doing, I am creating the data type manually every time. I am repeating the data type every time. And another thing is this is not secure as well. Okay, anyone can access your ID, your name, your marks, and make changes. Like in this case, suppose I want to update the marks. I can I can update the marks 33.4F. I can update now S1 student marks become 33.3. Okay, so this is not secure as well, right? So oops follow the principle of do not repeat yourself. And Java is strongly type object oriented programming. Okay, so let's talk about classes. I've already explained you little bit, but now I'll explain more about it. What is class? Okay, so first of all, class is a keyword. Okay, so this is a keyword means it has some predefined meaning. It has some predefined meaning and it provide you the blueprint. It provide you the blueprint or template. Okay, so if I talk about student, so student must have these fields. Okay, it provide you the blueprint that if you talk about a student class, then it must have these fields. I'll provide this blueprint. It must have these fields. Okay, so the class is that. Mm, so it provide the blueprint. Okay, now you can also say that a class is a user defined data type. So what I'm doing here, I am defining a student. You can imagine it as a data type which contain this data type, right? You can imagine it as a data type which has these field. Okay, now class do not occupy space. You can say what you are saying, sir. Here, when I defining int, string, float, it has a space. Okay, int take I think 4 bytes of memory. So how you can say that class do not occupy the space? Okay, so let me tell you, class only defines the blueprint when you create the object. When you create the object, when you write when you write this line, okay, when this line will execute, then only the space is allocated in the memory. When you when the compiler execute this line, then only space is executed in the memory. Okay, and let me tell you, uh, for object, so there are two types of memory: heap memory and stack memory. And for now, just understand, this is an object, new student. You write when you write new student, this creates a object. And object object always stored in a heap memory. In a object always stored in a heap memory. I will tell you in detail, in depth, as we move on. So, so when compiler execute this line, then only the space is allocated in the memory. When you imagine, you haven't written this line yet. Okay, and if I run the program, will compiler ex- allocate the memory for this class? Int, string, float? No, it will not. So when you create the object, when you write this line and when this line is execute, then only create the space. And for student one, for student one and for student two, different memory space will be created. I will tell you in the diagram. Don't worry. I will tell you the diagram, in the diagram, how this memory and stack memory works. I will draw and explain you. For now, so let's talk about object, and then after I'll tell you how this object and class occupies the memory. Okay, so object is a real world entity, have state and behavior. Okay, so imagine the student one as you. You are one object. You have some state, or you can say field. You can also say field. You have some state and behavior. Let's say you are a student. You might have behavior like study. You study. You have fields like you must have a roll number, name, and you must score some marks. So you have fields like marks, your age, your gender. These are fields. And behavior, like you study, you go to library or not. These are behaviors. Okay. And object occupies memory, particularly heap memory. Now imagine a scenario of a classroom. If you are the part of classroom, you are one object. Okay. Maybe your girlfriend is another object, and you and your girlfriend must have ID, name, and marks. Okay, I think you got it. You got this point. What is object and uh, classes? See, many students have difficulties to understand what is object and class. So I tried to simplify as much as I can. Okay, so here we created an object. This is called object creation. Object object creation. Okay, this also, in a fancy term, you can say, if you want to show off, you can also say initialization. sorry, instantiation. You can also say instantiation. Instant, instantiation. Okay. This is object creation. Here you create an object. This is object creation. And you can also say instantiation if you want to show. Like now, an object represent a real world entity as I told you. So it has identity, means who is it? Imagine you as an object. It has state. What it has? You have what? ID, marks, and name, right? And behaviors, like what it can do. So imagine you are a student. What you can do? You can study. You can go to library. Okay. You can eat. Okay. You can bunk classes, right? So these are behaviors. Oh, these are behavior. The object shows these behavior. The object may show these behaviors like studies, like go to library, like that. Okay. Now let me now I'll tell you how the memory will allocate in heap and stack. So let's imagine this is stack memory and this is heap memory. Okay. This is stack memory and this is heap memory. Okay. Now, as I told you, when you create an object, when you create an object always store in a heap memory. So let's imagine, let's imagine this is a program. I have meant this line for now, and also this line, also this one. Okay. Now, as you know, our program always execution with start with main method. So this when you run this program, this main method will execute. Okay, so this line is commented, so just compiler ignore this line, and uh, your and you and the pointer will point to this 20 line number 21. When compiler see, oh, there is a object creation, right? So compiler will so compiler will see where is this student class. So compiler will go to this class, student class, and see, oh, there is a int field, then a string field, and then float. Now, now compiler will allocate memory for student one. How this will work, I'll tell you. So start with main memory, sorry, main method. Compiler will see student. Compiler see student stu1 equals to new student. New student means you have to create an object of in string and float. Now compiler will allocate memory in heap area. in heap area like this, in for string and for float. Okay, so for what is the field name? ID. Yeah, so for ID, for name, and for float. And initially, if you see here, we do not initialize that what is the ID of student one. Okay, we haven't initialized it yet. So compiler will uh, def- write initialize with their default value. So what is the default value of int? That is 0. And what is the default value of string? That is null. See, in actually the string also stores the reference of another string class, but for now, for simplicity, I'm just writing null here. Okay, later on when I'll teach you string, I'll tell you how string stores uh, reference of object. For now, just imagine name as null. Okay, here null will be stored. Now for float, default value is 0.0. Now for student 1, this value will be initialized in memory, in heap memory to be precise, and this memory also have some address. Right? Please excuse my handwriting. So this object I've created here, this must have a memory address. Let's say it has memory address 1000. Okay, it has memory address 1000. Now this variable, this student ste stu1, that student stores the reference, means the memory address of what, of this object I have created here. So this stored the memory address, let's say 1000. So student 1 act as a, you can say it is act as a reference variable. Reference variable. What is reference variable? A variable which stores the memory address. A reference variable is a variable which stores the memory address. Student 1 object. So when you create a student 1 new student, when you create write new student, the object will see there is a equal to sign. So when there is a equal to sign, the uh, initialization always start from right to left in Java, or any other programming language as well. So always the initialization start from right to left like this. If you write int a equals to 10, means this 10, this 10, that means a store the value 10. Okay. So when you create object, when you write new student, means the object will create in a memory. Object will create in a heap memory, and the address, the memory address will be initialized to student 1. I hope you will understand. I hope you will got it. Okay, what I'm trying to explain you. Okay, I think you got the clarity of how this will work. So let me show you. one thing also. Now, if I print S1, what will it will print? It will print the memory address S1, sorry, STU1. If I print STU1, what it will print? Say, it will print the memory address where this new student means their student, where the student object is stored in a heap area. Now let me run this. So if you, I can clean this first. Wait, now I'll run this again. Why it is not? Yeah. So see, you will see the address. You will see the memory address where this object is created. So stu1 stu1 act as a what reference variable. Okay, now got it. Now what if I create another object, then will it store in a same memory, in same memory address? In, let's see, if I'll create another object, let's say stu2. Now what will happen? Will this memory address will be same? Now if I'll print stu1 and stu2, will the memory address will be same? No, it will not. See, the memory address of stu1 is this and stu2 is this one. Okay, you can also do it like this. u1 was equal to stu2. It will check, it will uh, check the memory address. If it equals, then it will print true, else it will print false. See, this print false means the stu1 and stu2 have different memory address. Now what happened in the memory, I'll tell you. So when you create stu2 means student 2, what happened? Let me erase this. So when you write this, then another memory will have created for student 2, and inside this there will be a int field, there will be a string field, and also there will be a float field. And let's say the memory address of this is 2000, then your stu2 variable will store the memory address 2000, mean the stu2 will store the reference of this memory where this stored, where this is stored. These fields are stored and initialize with their default value. Right? If you create one more, another object will create with separate memory location in heap area. I think you got the point what I'm trying to say. Now, what is the new keyword? What is the new keyword? So let me tell you, I will talk about this um, behavior or method, you can say. I will explain how you can create this. First, let's try to understand what is the role of new. So basically, new is a keyword in Java. So what it does, so memory is allocated on heap area. So new, when you use new, so memory is allocated in heap area. Means this object, the memory for this object will create in a heap area, and the class constructor is called. For now, ignore this point. I will explain what is constructor, then you automatically understand this point. This point. A reference address means memory address to the object is returned. Means what? For this object, the memory address is 1000, and 1000 is returned. Means this 1000 is initialized to stu1. Okay, I'll say I will say it again. The reference means address to the object. What is the address to the object? 1000. 1000 will 1000 is returned. 1000 is returned to, mean this in simple term 1000 is assigned to stu1. Okay, I tried to simplify as much as I can. I hope you will understand what I'm trying to say. Now, let's talk about ways to initialize the object. Till now, we haven't initialized the object, means we haven't, for student 1, we haven't stored the ID, name, and the marks of student 1. How we can initialize in the object? So there are three ways: by reference variable, by using methods, or you can say functions, or by constructor. Now, let's see it one by one. For now, I will erase this, and don't worry about this. You will get these nodes. I'll create. I have created these nodes, and all the important points, codes, all of these are written in this nodes itself. So for notes, you don't have to worry about it. I'll share it in the description. You will download from there. Okay, let's talk about by reference variable. How to initialize the object with reference variable. And one more thing for now, if I'll try to print student1 dot id, why I'm writing s1 b plus plus stu1 dot name. I'll tell you what I'm writing. Just give me a minute. stu1 dot mark. If I'll print what the value it will print. See, for student one dot id means means student one id is 0. Student one name is what? Null. And student one marks is 0.0. So it automatically initialize with their default value of their data types. For for id it is int data type, and the default value of int is what? 0. That's why it is initializing the id with 0, and for a string it is null. That's why it is initializing with null value, and for float it is 0.0 only. That's why it uh, is initializing like this. Okay, let me tell you what is this dot says. Dot means stu1 dot id. What it means? So it says stu1 1 dot id. It says so stu1. This is a reference variable. So it says go to this address, 1000 address, and print and get me the id. It says stu1 dot id. Dot says go to this memory address of this reference variable means 1000. Go to this 1000 and get me the id, and get me the id. So get me the id, so this id will point out and it will print. If I'll say stu1 dot name means dot says go to this memory address stu1, go to this memory address and print, or you can say get me the name. Okay, whatever the value it has, print or get it. Okay, if you say stu1 dot marks, so dot says go to this address and print the marks, and print or get it the marks. So if I'll say, let's say float a equals to stu1 dot marks, I'll tell you practically. If I'll say int a equals to stu1 dot id, okay, and now I'll print a. What it will print? So it will print 0 only. See, 0. If I say if I say string str equals to this, and I'll try to print these str, mean what it will say, what it will print? It will print null only. Okay, it will print null only. So I hope you got it what I'm trying to say. Let me now erase this. How I can, yeah, what it will open. How I can remove this. Let me remove these kacharas. Okay. And how I can remove this scale. Yeah. Now let's see how you can initialize these variable. You can write like this. You can, in a same way, you can write like this: stu1 dot id. Let's say you want to initialize with 01. ID is 01. You can initialize like this: stu1 dot name. Let's say Raj. stu1 dot, let's say, marks equals to 98.5 f. Now these value, this 01 is stored in student 1 id. This name Raj is stored in a student 1 name. So this is a heap memory, and where it will store. So first, initially it is initialized with 0, and this is initialized with null, and this is initialized with float value 0.0. Now it will initialize with 01 only, and this will Raj, and this will float will become 98 point whatever I have written 5 or something. Okay, memory address is 1000. Please excuse my handwriting because it is very difficult to write in a pen tab. Now if I print if I print the same line, what it will print? See, earlier the values are 0, null, and 0.0. Now the values are 1, Raj, and 98.5. Okay, so that's how you can initialize you reference variable with reference variable. See, student 1, you can say it as a reference variable. So I have told you earlier also. So go to, if I'll write student 1 dot id, means go to this reference variable and get me the id, whatever the id is. Return the id of student 1. If I'll say student 1 dot name, means return the name of student 1, whatever the name of student 1, return that. I hope you got it. I hope you got it. Okay, now let's talk about method. What is method? See, I have told you earlier. So this student may have a method like study method, or function, or behavior, whatever you want to name it. You can void, let's say, study. Okay, basically this is function only. How you can write a function, how you can uh, write function in Java. You you may read written like this: public static void, whatever is the function name. Okay, for now I'm skipping these lines, public and static. Okay, but you can say it as a function only. This is function or method, whatever you want to use. So now study. So may this student, uh, so name plus has marks, whatever marks. See, now if I have created one method study. How I can access this method? stu1 dot study. That's how I can access. Now, if I run this program, what it will print? So Raj has marks th- that much. Okay, let me now tell you how this method will execute in a memory. So before that, I have a question. Is this method will store in a heap memory or in a stack memory? While running this program, these method will store in a heap memory or in a stack memory. I will tell you now. So for these, for now I have removed this and also this, and create. So oh, that this is a memory address of student one. Okay, let me remove all of this. Yeah, memory address is what? 1000. Fine. Now, how this executes, how this line will execute. So let me comment this line first, and this also, and this one too. Now, as I told you earlier, your program execution starts from main method only. So main method start, then compiler will see object. So it will create object in a heap memory like this. Okay, it will create a object like this. Now, and the reference of this object will store in the reference variable. Okay, now these are commented lines, so compiler just ignore this line, and compiler point it to line number 17. So here compiler see student1 dot study means study method has been called out. So compiler go to your student class and see void study method, and it will create that method in a stack memory, in a stack memory. Now how it will work? So when compilers see stu1 dot study, so compiler will go to this method. So this method will execute study method will execute and it will print whatever you have written here system.out.println name marks it will print and the pointer will execute and pointer will come to line number 29 means this method will execute this method when this method will execute okay this will erase from your stack memory and it will just do and it will just print the statement uh, you whatever the statement you have written here it will just print the statement and this method will be call off from the stack memory only. I hope you got it how the memory will be allocated and deallocated how the stack and heap memory works. See I will I have I am telling you in detail how they how these things work internally. Now for constructor, uh, before going to constructor, now let's first understand types of variables in Java. Now I will tell you what is instance variable. So instance variable here we declare int, string name and double. Here we declare these variables. These variables are called instance variable. These variables are called instance variable. So let me tell you some properties of instance variable. So it, it is declared inside class but outside method. Mm, What it means here, this is a class, right? This is declared uh, inside the class, okay? But outside, see, this is a method. Outside this method, okay, you can declare it anywhere, no issue. You can declare here also, no issue with that. But what I'm trying to say, it is declared inside the class but outside the method. Means this will declare outside this scope, this curly braces, this scope, this scope, right? It will declare outside the method. Suppose there is another method, let's say study one. Okay, so it will declare outside this method always, but inside the class, right? Belongs to an object. So when you create the object, these variable will be initialized, right? This variable will be created and initialized. When you create an object, this variable will create and initialize with their default value of their data types. Each object has its own copy as we have seen earlier. Here, when we create student 1, it separate memory. In separate memory, these variables are created. If I'll create student 2, if I'll create student 2 object, these variables, these int, name, and float will be created in separate memory location, in separate memory lake. location. Let's say here int, here name, and here float. Okay, and the memory location will 2000. I have shown you earlier as well. I've shown you earlier as well. Okay, stored in a heap memory inside object. These variable stored in a heap memory. Yeah, pretty obvious. And see, the default value of instance variable is the default value of their data type. I have told you earlier as well. For int 0, for string null, for float it is a 0.0, point 0, for boolean it will be false, right? These are instance variable, right? When you declare, when you create an object, let's say you create student s1 object, and these value you will declare, and we create s2 object and you declare these values. So s1 and s2, both reference variable, have different copies, different copies of id, name, and marks. Yeah, I hope you got it. Each object stores its own data type, right? Now let's talk about local variable. What is local variable? Now, uh, let me show you practically. Now imagine a method, let's say void uh, calculate grade. Okay, let's say this is a method which calculate the grade. So string, let's say we initialize, we declare a variable grade, and if the mark will greater than equals to 90, then we can, then only we say uh, grade equals to a, right? And uh, uh, let make it simpler, else grade equals to, let's say, b. Now I'll print the grade, whatever the grade is. Grade equals to, right? I'm writing this. Now if I'll student one dot calculate grade. So first I have to initialize the grade, right? So I will remove these, and I have uncommented these lines. Now uh, what it will, now how this will work. So for obviously method is execution, start program execution starts from main method only. Object is created, right? Object variables, object instance variables are initialized. So student one id is 1, student name is Raj, and student marks is 98.5 something. Okay, now I'll print the student one name, id, and marks. Okay, now the student one dot study method will be called, and it will print that student means Raj has marks whatever it has. Now it will call calculate grade marks. So student 1 calculate grade will be called. Calculate grade will be called, and again string grade, this variable will be declared, and if the marks is 90 or greater than 90, then grade will be A, else the grade will be B, and it will print the grade. That's how the program execution works. Let me run and show you. Fine. So it will print the name, marks, and IDs, and Raj has marks itna, and grade is A, right? So you how it will work. Let me show you again. So I'll just show for mm, calculate grade only. Fine. Okay. So this calculate grade will this calculate grade method will create in a heap memory, heap area. Fine. And it has one variable, name it as grade. So grade will be initialized. Sorry, grade will be declared, not initialized yet. Now it will check the condition. It will check the condition. What condition? It will check if marks is greater than 90 or not. Now it will check, see the student 1 marks is that much, so it will greater than equals to 90. So now grade will initialize as A. Okay. Now else part is else block will not execute, and it will just print the grade, and uh, pointer will move to line number 34. When these line execute, when line number 34 will execute, okay, the method, this method will be call of, means deallocate from stack area. Okay. Now what happen, it will deallocate and the pointer will move to line number 16. Line number 16. Now the main method also executes. So the main method also executes. So the pointer will, here the pointer will point to line number 16, and the main method also get executed, no more line to execute. So now also this main method also deallocated from stack memory. Fine. These this main method also gets deallocated. Oh, then your student1 reference variable, which is pointing to address 1000, also gets removed. Okay. Now no no more, now no one pointing to reference to address memory address 1000. No reference variable, no reference variable is pointing to memory address 1000. Fine. You might wonder, so if the execution is completed from stack area, it will deallocate. Now, what about the heap area? Who will deallocate the memory? Okay, who will remove this object from heap area? Okay, so if you are if you are using Java programming language, then in Java there is a concept called garbage collector. Garbage collector, whose main job is to keep scanning the heap memory and uh, find out any object whose reference variable, that is student one, does not exist. So for this memory address for 1000, there is no reference variable pointing to 1000, right? So this object become referenceless. Okay, this object is a becomes referenceless. Okay, because no reference variable is pointing to this object. So the garbage collector automatically deallocate the memory. Garbage collector automatically delete this object from heap memory. Okay, but garbage collector concept is only in Java. If you are using C programming or C++, you have to manually delete the this object in a from heap area. But in Java, we have a garbage collector whose main job is to keep scanning the heap area, to keep scanning the heap area and find any referenceless object. And if garbage collector finds any referenceless object, it will delete that object from heap area. That's how it will work. So I'll tell you, I have told you the entire program execution, how the program execute in a stack starts, how the program starts execution, then object creation, then initialization, then how this method call in a stack memory, and will how this method have and how this method will call and deallocate, how Java deallocate the memory or delete the object from their stack and heap memory respectively. I have told you in detail. Now let's talk about the static variable. What is static variable? Okay, so means first I have told you the local variable. So let's see some points about local variables. So it declare inside the method constructor or a block. Constructor you can ignore this for now. Told when I will tell you constructor, what is constructor, then you will automatically understand this. For now, local variable only declare inside method. This is a local variable. Here grade is a local variable because it is only declare inside the method or a block. What is block? I I told you. I will tell you. So this is a block only. this is a block, this is a block. Okay, so a local variable can access inside the block only. So now let's see. Uh, Suppose I declare and initialize a variable int a equals to 10. Now, if I want to access a, will I am able to access? Will I am able to access the variable a? See, there is an error. It says a cannot be resolved to a variable. See, I won't able to access this a variable. Why? Because because it is inside this block. I can't access this variable outside this curly braces. If I will write the same line, if I will write the same line inside this block, then see there is no error. If I'll print, it will print also. If I'll print, it will print C10. See, it will print. So this is a block. Fine. Now another property is exist only while the method is executing. I have told you that when calculate grade is called, then only grade is declared. Okay, then only grade is declared. And when this if block is execute, then the grade is initialized. Okay, declare means you are declaring a variable. Initialization means you are um, initializing means you are putting some value to this variable. You can say this, you are putting some values to this variable. That's initialization. And declaring means you are declaring that grade is of string type, but you are not initializing yet. Means this grade has no value yet. Okay. Now let's see the another point. Uh, Store in a stack memory, as I have told you, and must be initialized before using it. So, in case of instance variable, you can see if I will not initialize the instance variable, the default value will automatically be initialized, but in it is not in local variable. Okay, you have to initialize this variable before using it. If you won't initialize, it will give you error, like you can see here. You can see the error. The local variable may not have been initialized, right? So you must have to initialize this variable before using it. Now, as I have written here, grade is a local variable, exists only inside calculate grade method, and it is destroyed when the method is end. See, this variable is this local variable is destroyed when the method is ends. Okay. Now let's talk about static variable. What is static variable? So first of all, static is a keyword. Okay. It is declared using a static keyword. It belongs to a class, not an object. I will tell you what it means. So let's say, where is my VS code? I'll write this variable here only for better readability. And this is a method for first format. Yeah. So now let's see what is static variable. Now, let's say you are a student, and in a class there are hundreds of students, and all belongs to one school. Yeah, you all belongs to one school only. So maybe I'll write like this: string school name equals to, let's say, XYZ. Yeah, you all belongs to this school. Okay, but here you have to write static keyword. Why? Because static belongs to class, not object. So when you write static, it will belongs to class. Every time means every time you call an object student one, this school name will automatically initialize, and it exists as a one copy only. Means what? I means suppose you have not write static here. Now you can write initialize. Now student one dot school name. If I'll print this, if I'll print this, what it will print? Let me comment out this one. Student one dot school name. It will print XYZ school only. Yeah. Now let's say I'll create another object. Let's say I'll create another object, student two. Fine. And I'll print mm, this. What it will print? It will print the same school name. Fine. Now, if I will change the school name, what if I will change the school name? Let's say, okay, sorry. I have to now student two dot school name. Then what it will print? It will must print the same school name. Fine. Now, if I will change the school name of student two, what it will print? Let's say ABC and let's say ABC school. Now, what it will print? It will print ABC school only. Fine. So we have, so I have changed the school name ABC school. Okay. What if, what if I use static here? I use static here. Now, what it will print? Here, in this case, it will print the same. I have initialized it again and print the school name. Okay. Now, what if I'll print the school name of student one again? What if I'll print the school name of student one again? What it will print? See here, the student one school name also changes. Also change. The student one school name also change. Right? Suppose I, I'll I will remove this. Suppose I have not written the static keyword yet. Now I'll print. Now I'll print. See, the student one school name is XYZ only. Right now, the student one school name is XYZ only. Means what it means, I'll tell you in memory how. Let me remove this first. Now, so there are two objects, student one and student two. Fine. So school name equals to whatever school name of student one, that is XYZ. Okay. School name of student one is XYZ. Now here school name of student two. As I told you, the memory address, the all means student one and student two all have different memory location in heap area. So here also school name is XYZ. Okay, it will initialize with XYZ. Now I have changed the school name. I have changed the school name to ABC. So change it will change to ABC. Fine. But here student one school name is XYZ and it will not change because these school names are in different memory location. Are in different memory location. Now, what if what if I use static keyword? If I'll use the static keyword here, now you can see the the school name of student one also change. The school name of student one also change. But why? But why? So if you use static keyword, then only one copy, only one copy of memory will exist. So if you use static keyword in a heap area, uh, let's say what is why it is leave it. Now let's say this is a heap memory. I have extended the heap memory. Nothing extra I have done. So when you use static variable, so the school name only one variable only one variable will exist. What I mean, the memory will end here. Memory 1000 will end here, right? Fine. Now when you write school name, so SCH2 school name variable will declare and it will initialize with XYZ, and these this memory location, let's say this memory location is 3000, it will share this memory location, will share by this object as well as this object as well. Means only what I mean is only only one copy of school name will exist. Only one copy of school name will exist if I use static keyword, and it will share uh, it will share by entire class. Okay, if I if I'll create another object, if I'll create another object here, then this school name also shared by student 3 also. This school name also shared by student 3. Okay, all the object belongs to student class have only one school name. Only one school name exists. Okay, if you change the school name to XYZ, from XYZ to ABC, the school name also update for student 1, student 2, and another, and the rest of student object you will create. Okay, so the school name will change to ABC only. All the object belongs to student class. That is static keyword. That is a meaning of static keyword. That is a use of static keyword. I have told you. I have tell you in detail. Now let's see few points. Belongs to class, as I have told you. Only one copy exists and shared by all the objects. It has only one copy and it is shared by all the objects stored in a memory area. See, here I have uh, tell you that static variable is stored in a heap area, but actually, because I don't want to complicate much, but actually, static variable stored in a memory area. Now you ask me what is memory area? So let's point it. Yeah. So see this diagram. So this is a JVM. Okay. First, first let me explain what is JVM. Then I'll tell you the memory area. What is memory area? Okay. Now let's talk about. Then I will come to stack memory and heap memory. So let's talk about JVM. So what is JVM? JVM is Java Virtual Machine. It is a runtime engine that runs Java program. So see, this is a Java program. This is a Java program, and who run this program? Who will execute this program? Okay, so the JVM, the Java Virtual Machine, will execute this program. Okay, it so you might have listened or read somewhere that Java is platform independent. Okay, Java is platform independent. So Java code can run anywhere. It will compile once, and now and if it will compile once and you can run that compiled code anywhere in the machine. So uh, if I'll give you the compile code of Java, then you can run that code in your Windows machine, in another Mac machine, in another Windows machine as well, without compiling it again. Okay, how it will work, I'll tell you. So it take a compiled Java bytecode dot class file and convert it into machine code so the system can execute it. What it is. So now this is a main.java class I have created. But have you noticed I haven't created main.class file. and student dot class file. Have you noticed? I haven't created that. My compiler, my Java compiler automatically create these files. Let me delete. Let me delete these files. Let me delete these files. Okay. Now I have deleted. I have deleted these files for now. Warning come that I will. Yeah. Now let me run this program. Why it is not? Yeah. Let me run it again. So okay. Before you are saying that dot class file also exists. I have deleted that file and I don't know why it will not created again. I think it will created, but it will not shown here. I don't know why. But uh, but you can understand it. Like if you take a compile.java class file and convert it into machine. So JVM work is to take that dot class file that has exist uh, here. I have deleted that file. It when I'll run this file, so first the dot class file will be created, and then that dot dot class file will convert it into machine code. Okay, so the system will execute. The JVM is a platform independent. JVM is platform independent, which makes um, so JVM makes Java program platform independent. Okay, so JVM follows the right ones and run anywhere. Now, how the flow how the flow of Java program will now that your .java file is compiled. Okay, so Java compiler, your Java compiler name is Java C. Okay, uh, uh, similarly, your C programming language in your C programming language, your compiler name is GCC, and in C++, your compiler name is G++. Similarly, in Java, the compiler name is Java C, and your Java file is compiled into dot class file, that is bytecode file, and now that dot class file will executed by JVM, means that JVM convert that dot class file into machine code, means machine code means 01 format. Okay, in bytecode, the your program will convert it into hexadecimal form. Okay, and JVM convert that hexadecimal form into machine code. Okay, and inside JVM, there are memory areas. So let me explain this one. So we have thread area and data area. So thread I will teach you in multi-threading. When I will teach multi-threading, I will teach about what is thread. For now, just understand uh, stack area and again stack area. So Java is multi-threaded language. That's why you have seen multiple threads here. Okay, but uh, for now, just focus on method area. So when you declare a static variable, uh, inside data area there is memory area and heap area. So a static variable will store in a memory area. Okay, so your school name ABC school is stored in a memory area. Fine. And you have in heap area you have all the object will stored, and the object memory address, as you can see here, the object memory address, this one, 0xa1b12, is stored in a stack area, stored by that reference variable. Fine. And as I have told you, that string in heap, so this is another concept. If I will explain here, the video will be very long, and that's not the objective of this lecture, right? Here we um, try to understand the oops concepts. Mm, I will tell the string. I'll tell the string concepts in my string lecture. For now, just understand that name Rahul is stored here like that. Now I'll tell you what is. So you must have understand till now what is a static variable. Now I'll explain you about stack and heap memory. For now, just understand on this. Just understand this point. So in stack memory, all your local variables, all your functions or methods, and returned address. Return address means what? Means the address 1000. It is returned to here. The the student one reference variable, and this 1000 address is returned to student one. Okay, so all the returned address will be stored in a stack area. All your methods or functions, you can say, is stored in a stack area. All your local variables, so this calculate grade has a local variable grade, so this will also store in a stack area. Fine. Okay, now you will understand these points also as I proceed in a lecture. You will understood this point. You will understand this point also. Now I'll explain you heap memory. So heap memory stores the object and large data structures. So here you can see these object and these object are stored in a heap area only. Fine. Okay. And these point I have already told you that manually manage. If you are using C++ or C programming, you have to manually manage, means delete the uh, referenceless object from heap memory. But in Java, garbage collector makes your life easier. Garbage collector automatically deletes the referenceless object. Okay, now I have already explained how these memories work. Just I have written uh, the steps how these memory will work. Now let's proceed to. So let's start our constructor topic. So what we have seen till now. I'm also revising the whatever we have learned. So let's say we have a class student, and in this we have fields like int id, let's say string name, and uh, double mark. Okay, fine. Now, as if I create the object of this class, student, let's say s1 equals to new student. If I create the object of this class, okay, now, and how we can initialize the variable? How can we initialize uh, these loop instance variables? S1 dot id equals to, let's say, 1. S1 dot name equals to, let's say, Raj, and S1 dot marks equals to, let's say, 96.5. Right? Fine. We have initialized, and let's say we want to print. So can print these S1 dot name plus S1 dot id plus S1 dot marks. Yeah, pretty obvious. If I run, yeah, so we will get our marks, ID, and name, right? So far, uh, we we have initialized using reference variable. So I have told you in earlier previously that there are three ways to initialize an object. Here I have written somewhere. Yeah. So there are three ways to initialize an object, right? So first we have seen a reference variable, then method. Using method, we can initialize the object. And now we are going to see how we can initialize the object by constructor, by using constructor. Fine. Now, what is a constructor? So constructor is nothing but a special Java member, or you can say function. It is like a function, but it is a special function of a class that executed automatically, when an object of a class is created. So what is a constructor? Is just a function, is just a special function which get executed automatically. See, let's say we have a method, void study, fine, and let's, here it is written I am the I'm studying, fine. So this is a what? This is a method, okay, and you have to explicitly call this method like s1 dot study. Then only this method will execute, fine. Otherwise, it will not execute. You have to call this method explicitly. Then only it will execute. But in case of constructor, it will automatically execute when you create an object. When you create an object, and when we create an object in this line number 12, this is the object creation part. And when this line execute, the constructor automatically get executed, and it it Initialize. Its primary use is to initialize the instance variable. And what is instance variable? I have told you these are instance variable. Okay, it's primarily used for initializing the instance variable. Okay, set instance set the initial state, default state, where and we will see that. Okay, uh, now how we can create an constructor. How we can create a constructor? So the syntax is pretty simple. So for constructor, the name of a constructor should always be same as the name of class student, right? The name of a student is the name of constructor is always same as the name of that class. This point you have to note it. Fine. Now we will see how we can initialize using constructor. Let's say we want id equals to 1, let's say 0, name equals to xy xyz, and name and mark equals to, let's say, 101, 100 maybe. Now we don't have to initialize here. Okay, if we run if we run our program, what will be the output? See, so my object is initialized automatically. Okay, so constructor do this work. Let's see the how the program flow. So as we know, the execution always starts from the main method only. So this line number 16 will run, and space is created in stack memory for main method. Fine. Now this line number 17 will run, and as I told you earlier, this is equal to. So first right side will execute. Okay, right side will execute new student. New student means create an object. So space now, let's say this is memory location 1000. Now space is created. Space will be created in heap area, and these variables are initialized with their default value. ID, yeah, and name and mark. Now and the default value will be initialized Now now this line number 6 will execute. Okay, and when the line number 6 will execute, the variables, the instance variable, are initialized with whatever the value we have provide in constructor. So x, y, z, and maybe this was 100. Yeah. So these values are updated in heap area. This instance variable will get updated, and the memory address will be passed to S1. S1. Okay. And now we are calling the S1 dot name, S1 dot ID, and S1 dot marks. So S1, this is it's the reference variable. So S1 dot means go inside that memory address. Okay, dot means go inside the thousand memory address and get me the ID and get me the ID. Fine. Now, so so we have seen what is constructor, and its primary use is to initialize the instance variable. Now, some key characteristic of constructor. The constructor name must be same as class name. I have already told you. Uh, Most important point is it does not return anything. Constructor do not have any return type, not even void. See, void is also a return type. Okay, void is also a return type. So constructor do not have any any return types. If I write void here, you'll get an error. Okay, and if I run, see, when first I'll show you without void. Without void, the name initialize with xyz means the constructor run. Okay, now when I put the void, what I will get? We'll get the default value. We will get the default value means this will not act as a constructor. This will not act as a constructor now. Okay, means the when we create an object, when we create an object, this these these line will not run. That's why we are getting the default value. Fine. And if we write int, we will get an error. This method must return int. We will means if we put any return type here, this will not act as a constructor. Then this will act as a method, and we will not able to initialize our variables. Now it invoke automatically when new keyword is used. As I told you, when we create an object, see, new keyword is what is the role of new keyword? I have told you, that memory is allocated on heap area. What is the use of heap? Heap folder. What is the use of new keyword? Memory is allocated on heap area. the constructor is called. The constructor is called. When memory is allocated, then the constructor is called and the reference means address of the object is returned. Okay, the address of this object will return to s1 reference variable. S1 is a reference variable. Fine. Let's proceed further. These points you can leave for now. As we proceed further, you will understand these points. Why constructor is important? Without constructor, object may be created in invalid or incomplete state. Means we are not able to initialize the object. Okay, if the student object created without initializing, so the default value will be stored, and this may lead to logical error. Fine. So there are uh, three types of constructor. So first one is default constructor. Compiler it. So default constructor is provided by compiler only. Okay. So what happen is, suppose you have not written this. Fine. Now when you run this, when you run this, so the default value will be initialized. Okay. So the default constructor is, if you do not define any constructor, if you do not define any constructor, here in this case we do not define any constructor, Java automatically provides a default constructor. Then the Java automatically defines a default constructor. Means internally Java will provide a default constructor like this, student, but this is not visible. This is not visible. This is internally Java will provide. Okay. Now, now these are the example I have written here. I have also uh, put these examples. Now, this constructor takes no argument. Assign default value is added only if no constructor is defined. This is important line. This is important line. Let me highlight this. It is added only if no constructor is defined. Means what? So in this case, we have initialize one constructor. In this case, we have define one constructor. Fine. Now, will Java will Java create the default constructor if we explicitly define any constructor? Okay, no matter it is defining any values or not, it is initializing any values or not. Suppose I'll write like this. I I have not initialized any values, any variables. Now, will Java create this default constructor internally? If I explicitly define any constructor, will Java create any default constructor explicitly? No, Java will not. Default constructor is added only if only if no constructor is defined mm, by the programmer. Okay, if you do not if you do not define any constructor, then only Java will provide. Okay, so important point is if you define any constructor manually, Java will not provide any default constructor. Fine. Now, let's see no argument constructor. We have already seen this. We have already seen this. So class name is same as student name. Now the ID we have name and marks we have initialized. Fine. We have already seen the no argument constructor. Okay. Now let's talk about parameterized constructor used to initialize object with custom value. Fine. Let's see. This is important. This is important. Parameterized constructor is important. Now, if you want to initialize object with your own value, suppose object 1 has ID 1, name is let's say Raj, and marks is 98. Okay, and let's say you create an object student 2 equals to new student. Fine, and you want that student 1 ID is 2, name is let's say Sid, and the marks will be 95. Okay, but we have seen these methods like uh, but how we can initialize the object with different values, with different values. See one method is to use reference uh, variables like this name.id equals to whatever 1, and in s2 name.id s2 dot id equals to like this s2 dot id equals to 2. We can do like this, or we can create a method and initialize the value, but here we want how to initialize this value with using constructor. Okay, and now that we have seen no argument constructor and the default constructor, so using default constructor and no argument constructor, these um, separate value initialize with separate object with separate values are not possible. Fine. So we that's why parameterized constructor helps in to initialize the object with custom values like that I will show you. Like int I, we are passing arguments. We are passing arguments. Name, let's say string and n equals to, and let's say double marks. Now id equals to I, and name equals to let's say n, and mark equals to m. What I have done here, so we are passing three arguments. Okay, now when I'll create an object, I will pass these values, whatever value we want to initialize with. So we are passing ID is 1, name is Raj, and marks will be 98. Fine. In same way, we will pass two, name is Sid and the marks is 95. In same way, we can pass. Now, what happen is, so when the student one object will create these value ID1, name Raj and marks, name and marks will pass to the argument of constructor, means here when when the object is created, is the id is 1. Okay, now the id will pass here, so id become 1, like this. Id is 1. Now when we create object of name, so name will initialize with Raj and the marks will initialize with this. So this will happen internally. Fine. This will happen internally. When this object is created, these value will pass to the constructor and constructor initialize like this. Constructor initialize like this. Okay. Now, if we run, so first we will create S2, S2, S2. Now we can run, say different values are initialized. So object 1 gets Raj as a name, and see, we are printing name first. That's why you are saying name. A name, object to name is Sid. IDs, and see, all object, these S1 and S2 object initialize with different values, means custom values. Fine. Okay. So parameterized constructor used to initialize object with custom values. Fine. Now, we can also do like, suppose I'll write like this. Suppose I'll write like this. Then what happen? Then what will happen? Now we do not pass the marks. Fine. We do not pass the marks. Will this constructor run? Will this constructor run? Here you can see the marks will initialize with 98 and 95. Fine. Will this constructor run? Maybe you have a doubt like, I'm writing this constructor below that one. That's why this is not running. So let me clear your doubt. I'll run it again. Now you can see this constructor will not run. This constructor will not run at the time of object creation. But why? See, uh, we are passing three values, ID, name and marks. Okay, so when object will create, when object is creating, uh, so our compiler will match with the parameter. So this constructor will taking three parameter, three argument or parameter, whatever you want to say, three arguments. So this constructor will run only this constructor will run. Now suppose I'm not initialize marks. Suppose I'm not initialize marks. Now what will happen if I run this? So I'm getting the default marks, that is the default value of double. What happened? Then what will happen? So we are passing two parameters. We are passing two parameters. So our compiler will match. Hey, is there any constructor which have two parameters? Which have two parameters? Is there any? So it will match with, yeah. So we have a constructor with two parameters. So this constructor will execute, and since we do not pass the marks, so the default value of marks will initialize, and the default value is what? The default value is the default value of double, that is 0.0. Fine. I hope you got it, what I'm trying to say. Now, uh, if let's say I'm commenting for now. Now, see, you will get an error. You will get an error. The compiler is saying that, hey, you pass here two values. You pass two parameters here, but you haven't in declare any constructor which are taking two parameters, which are taking two parameters. That's why this is getting error. This will get error. Fine. Now, if I initialize with let's say 54, now the error will resolve. The compiler will saying that, hey, is there any constructor initial defined with three parameter? Uh, yeah, this we are passing here. We are passing three parameter. So we have, so we do not get any error. I hope you got it. Now, what if we write here int? What if we write here int? Sorry, int. My bad. ID and pass the ID. Okay, and instead of n, we write name. Same name as instance variable, and marks. We're passing marks, and here we'll also initialize. Now, will we get any error? Will we get any error? See, although we are passing the values, although we are passing the values, ID, marks, and name, but in output we are getting the default value. Why is that? Why is that? Think about it. So here you can see the warning. The assignment to the variable id has no effect. What is mean? What it is mean? Means the compiler will get confused. The compiler will get confused now. Now, let us see what is happening at the memory level. See, the program execution starts from here. So for now, I have commented this line and these also. So the program execution, the program execution starts from main method. So new student create object in memory, in heap memory to specify. So let us create a memory, allocate memory for the object id, name, and marks. Now the default value will be initialized. So the default value for int is 0, string is null, and for float it will be 0.0. Now what happened? And the reference variable s1 stores the memory address of this object. Fine. So here this is a main method area. Now here s1 stores 1000. Fine. Now what happened is that a constructor is called. Fine. A constructor is called. Actually the constructor stored in a so the JVM calls the constructor from memory area. Okay. And a new constructor stack frame. So constructor stack frame will be called, and what we have assigned. So id equals to id, name equals to name, and marks equals to marks. Fine. And the parameters are 1, Raj, and 98. Fine. So these parameter passes in there here. These parameter 1, Raj, and 98 passes as a constructor parameter. These parameters 1, Raj, and marks passes as argument of the constructor. So id is 1, name is Raj, and marks is 98 point something. Now what happened is that so id equals to 1, and see, id equals to id is here, and name equals to name, and marks equals to marks. Now so these are local variable. Fine. Because these variable are accessible, this id is accessible within the scope, within these curly braces. Fine. This id is a local variable. Here this id is a local variable. Now this leads to a problem known as variable shadowing. What is variable shadowing? So variable shadowing is occur when a variable declare within the inner scope within the inner scope, let's say this curly braces, and has the same name as the variable in outer scope. Okay, so this id is also declared in a inner scope, means as a local variable. Fine. And this id has the same name also declared outside the scope, means as a instance variable, or you can say global variable. This same id is declared as a local variable as well as an instance variable. So this leads to a problem known as variable shadowing. And how JVM resolve this issue? So the inner variable overrides the outer one. Means means this id equals to id considered as a local variable only. Internally, in internally it will be like 1 equals to 1, and name will be like Raj equals to Raj. Fine. And marks 98 equals to 98. So internally this will happen because Java because Java compiler uh, overrides overrides the outer scope, and it will considered as a local variable. So this id equals to id, both are considered as local variable. Fine. So these are considered as local variable. Fine. Now this now pointer your now your pointer comes to this line number 17, curly braces ends, and your your constructor will run, and your constructor runs. Now this now the pointer moves to line number 29, and it will print name s1 object 1, means s1 name, s1 id, and s1 dot marks. Here you can see, because this is considered as a local variable, this instance variable won't be updated. This is considered as instance variable, sorry, local variable. That is why your instance variable won't updated, and you will see, wait, what happened? And let me just comment it out, and I'll run. That is why you are saying that default value will be initialized. Let me run this. Yeah, run. That is why you are saying the instance variable are initialized with default value even after passing the parameter. Fine. This problem is known as a variable shadowing problem. Okay. And your compiler considered this as local variable only. both ID, this ID and this ID both are considered as local variable. So it will be like 1 equals to 1. Name is Raj equals to Raj. Marks 98 equals to 98. Nothing, nothing will be modified in the instance variable. That is why you are saying that the default value. Now, what's the solution then? Now, if we write this dot id here, also this dot name, and this dot what is marks. Now, if we write this keyword here, now let me run this. See, the values, the values are updated. The values are getting updated. Fine. Now, what is this? What is this keyword? Let me explain you. So, this keyword reference variable that refers to the current object of a class. What it means? It means, let me show you in my board, and let me rub this first. So, so when the object is created, fine, object is created in a heap area, and the reference is stored in a reference variable, that is S1. Now constructor frame is called from memory area, and here we write, so if we write this dot id, so this refers to the reference variable of current object, reference variable of current object. So what is current object? Reference variable, that is S1. Fine. Now internally this will be like S1. Mark my word, this keyword refers to the reference variable. What is reference variable here? S1. Reference variable of current object. So what is the this is a current object, this is a current object, and uh, reference variable of current object is S1. Reference variable of current object is S1. So internally this will be like S1 dot id equals to id. S1 dot name equals to name, and S1 dot marks equals to marks. Fine. Again, I am repeating. This keyword refers to the current object, refers to the reference variable of current object. And what is the current object here? Current object is this, and this memory address is stored in a reference variable S1. So this refers to, when you write this keyword here, so this refers to the current reference variable of current running object. Now we pass id, as 1. So here 1 will be stored, initialize with 1, and name is Raj, so initialize with Raj, and marks is 98. So this dot id, what is this dot id? Means s1 dot id. What is s1 dot id? S1 dot id is this only. So this will be updated. This will be updated. Now s1 dot name. What is s1 dot name? S1 dot name is here. So it will be updated as Raj. Now what is s1 dot marks? S1 dot mark is this one. Will be updated as 98. Fine. I have tried to make you understand at the memory level what is happening at the stack and heap memory. So you will get the better clarity of how these things work. I hope you have understood that. I hope you are understanding what I am trying to. I hope you guys understand what I'm trying to say here. Fine. Now we can also create object, another object. If we run, if we run, we'll see the for object 2, we are getting another, means whatever we pass in the object 2 parameter, we will get these values, because see, this refers to the current object. Fine. Now uh, this object work is done. Now this object will be created, new student as will be created again in different memory location in a heap area. ID something that marks and name created. The memory location will be allocated. This will be stored reference variable s2. Now when you call now again call the constructor for s2. Now this constructor refers to the current running object. This keyword refers to the current object running. What is the current object which is running? This one. And reference variable of this object is s2. So this will be like s2 dot id, s2 dot name, and s2 dot marks. Fine. And whatever values you passed in a parameter, it will be accordingly updated. Now let's move further and let's see what is constructor overloading. First, I'll tell you what do you mean by overloading. Overloading means multiple constructor with different parameter, means multiple methods or constructor with different parameter have same name but different parameter. Simply you can say like same name but different param parameters. Okay. Now see, here we have created this constructor also. We can create a default constructor also. Fine. We can create default constructor also. We can create a constructor having two parameters. We can create constructor having all the three parameters. Fine. We can also create like We can also create like these. If you want that, there will be uh, int marks, sorry, in rows, double double marks. Fine. We can also do like this. I should write this down. Why this is? Um, why this is? Oh, no, I'm doing it right. Yeah. No. Fine. Mhm. So here we declare a default constructor. We declare parameterized constructor with having two parameters. We again declare a parameterized constructor having two parameters but different instance, means a different types. This is int, this is double, and this parameter having one int and one string, and this having one int and one double. Now we can also create a constructor having three parameters. I no issue with that, but you can't do like this. But you can't do like this. Like if like you are declare and you can also do like this. So here you declare uh, three parameterized. Here you declare constructor having three parameter. First one is int, string, and then double. And you again create a constructor having three parameter, but the first value is, but the first it will take string, then double, and then int. So the arrangement of parameter are different. Here the arrangement are different. So you can also do like this. And if you run, let's print uh, name double and then int. Okay, and here, so first one is int, then name, then double. Fine. And if you pass, first one is having name, then any double value like 54.8, and then ID like it is happening. like 2. Now, if we run, if we run, see, first object creates, first object will create, then first object constructor will be called, for first object constructor will be called, and which constructor, which has first which having first parameter int, then string, and then double. So this constructor having first parameter int, name, and string, and then double. Fine. So this will be called, and this will get, this statement get printed. Now the second object creates, will be create, and the having, and which constructor will be called, constructor having first parameter is string, and then double, and then int. So, and this statement is printed. Now this statement execute, and this statement execute, and the value will be printed. Fine. This is method, sorry, constructor overloading. Class having multiple constructor with different parameters list. Fine. Here I also write one example, so you can refer this when I'll give you the notes. Fine. So many of you confuse that is constructor is a method. So I'll tell you, no. Constructor is a special method, and method is your method. So many of you confuse, is constructor is a method. So I'll say no. So there are some differences between constructor and method. First of all, constructor have same name as class, but if you talk about method, any name, any name you can give to a method. You can also give your girlfriend's name, but in case of constructor, same name, only same name as class. And constructor does not have any return type. See, void is also a return type. So constructor does not have even void. Fine. But method must have a return type. If you nothing is specified, you must have to specify void return type. If you won't declare int or double return type, you must uh, declare void return type, otherwise it will get error. And constructor automatically call, when constructor call, when we create an object, constructor automatically call, but in method you have to explicitly call. Fine. So this is a student method here, sorry, study method. This method is not called automatically. When we write this s1 dot study, then only this method will be called. When we write s1 dot study, then only this method will be called, and this I am studying statement will be executed. But in case of constructor, it will automatically call. If you not pass any values in a parameter, and suppose you haven't declared any constructor here, and I have to minimize. So now you say here, no, here we haven't declared any constructor, so no constructor will be called. But you, as I have told you earlier also, Java provides, your compiler provide a default constructor. Your compiler provides a default constructor. So constructor always run when you create object. Always a constructor will run. If you not declare any constructor, or automatically, Java compiler automatically declare a constructor, and this constructor will be called. What is the purpose? So the purpose of constructor is to initialize the value. Fine. Here, what you are doing, you passing values as a parameter, and that values are initialized to your object. When you create object, these value are initialized. Fine. And in method, mostly in method are used to define the variables, sorry, behaviors or any logic. For that purpose methods are used. Now let's talk about copy constructor. Now let's start with our next topic, that is copy constructor. This is interview asked topic and very important for interview purpose. So what is copy constructor? A copy constructor is a constructor that creates new object by copying the value from another object of same class. I know you nothing you have understood. Let me comment this all, and I will create new class. So stu- let's say main class again. No, demo demo.java. Fine. Here we create the static void main. Why small? No. By convention, the first letter would be in capital. That's why I'm changing. Now let's create class student int id string name, and let's say double marks. Okay, let's create a constructor. Let's create a constructor having parameters like int id, uh, string name, and double marks. And again, this dot id equals to id. I hope you got it what I am doing. Name equals to name, and this dot mark equals to marks. Fine. So we have created a class having instance variable int id, int string name, and double marks. Okay. And we also create a constructor. Fine. Now let's say we create object of this class. Okay. Now let me tell you one thing. When we write new student, when we write new student, let's say we pass id as 1, name as Raj, and marks as 97. Now this part this part is object creation. This part is object creation. This part is object creation. Okay. And when we create reference variable. When we write like as student S1, this is reference variable creation. This is reference variable creation. Fine. This is object creation and this is reference variable creation. Now, when we do like these, when we write like this, what we are saying, as I have told you many times, that when there is equal to, always the right side thing will execute first. So first the object will create and the address and the memory address of that object will be stored in this reference variable s1, and the reference variable always the same type of the reference variable is always the same type of the object type. Now we will proceed further to our copy constructor part. Okay, now let's say we create a reference variable of student, let's say s2. Fine, we haven't create any object here. In this we haven't create any object, we just declare a reference variable. If we pass s1 here, if we pass s1 here, what it means, let me print it and you will understand it. So let me print s1 dot id, then s1 dot name, then s1 dot mark. Why name is getting error? Yeah, so I haven't write this on here. Yeah, now copy this and here write s1, s2, sorry, s2 and s. Now what it will print? Guess the output. Guess the output. It will print the same. I think, yeah, it will print the same value which I have passed when object 1 is created. Okay, so it will print the same value. Now it what happened here is, let me erase at memory level. So see, everything I am telling, every concept I am teaching you, I have also explain what happened inside the memory. I have not just code it and make you understand. I will also tell what happened inside the memory. Fine. Now, when you create an object, this time I'm doing a little shorter way. So you pass ID as 1 and marks is this one. Okay. Now initialize with 0, null, and marks will, let's say, double value, that is why 0.2. Now constructor frame is called here. Okay, this dot id and the reference variable s1 stores the memory address. This will become s1 dot id equals to id. Okay, this will get updated as 1 as Raj as 97. Fine. Now what I have written here, so student s2 means we create, I have told you this is the reference variable creation. Okay, so here in stack area s2 s2 reference variable will be create. Fine. Now what value it initialize initially? Let's see let's see we haven't write here this thing and this thing. Now if we print s2, see the local variable s2 may not have been initialized, so you haven't initialized the value s2. So that's why you are getting error. Let's see, you will, if you initialize with s1, what it means, this s2 equals to s1 means the value, the whatever value the s1 has, it will initialize with the same value. So s1 stores the memory address, so that is why s2 also stores the memory address. Fine. And you may have doubt why this is saying the local variable s2 as local variable, because this is this s2 won't access, you won't able to access this s2 outside this scope, outside this main method. Outside this main method you haven't access this s2 variable. Fine. In this, in the same way, if we declare a method here in previous, here it, we declare a method here. If we declare any variable, we can't access outside this method. So this is also a method only. This is a main method. This is a demo class. If we declare here, let's say int n equals to 10, so this n is accessible throughout the class. Throughout the class we can access this variable. That is why it is saying this is local variable and storing the reference of another object, that is s1. That is why here you are saying what happened is that what happened here is s2 stores the same reference variable as 1000. Now you are accessing s2.id, means s2.id means go to address number 1000 and get me the id. What is the id? Id is 1. That is why 1 is printed here. Fine. So here we are copying the object. How we can copy the object? Now let's talk about copy constructor. So copy constructor, as I've told you, that uh, when a new object is created, when new object is created, the values from other object, Now, a copy constructor is a constructor that creates new object. Fine. That create new object means that this constructor will create a new object by copying the value. What it means that, so if you write student student S, let's say, what I have written here. So this is nothing but the syntax of copying object using constructor. See, copy constructor that create a new object. Here we are creating a new object by copying the values from another object of same class. Here we are creating a we are creating constructor, and in the constructor parameter what we are passing, we are passing another object, we are passing another object. Wait, this will be very clear to you, just wait. What I am saying, let's say this dot id, let me initialize this first, then I'll tell you what happened. S dot id. Now this dot, have patience, I will explain every single concept. Name is this. Now this dot marks equals to S dot marks. Now what happened here is, so this you already know, you are creating constructor passing three parameters, id, name and marks. What is this? Here you are creating constructor, no issue with that, but you are passing an object, you are passing an object. You are creating constructor, no issue with that, but in parameter you are passing the reference variable of another object. What you are passing, you are passing the reference variable. S is a reference variable of what? Of student class object. Now what happened is there, so let me create student s2 equals to new student. Let's say we pass s1. What happened here is, so you create another object, fine, no issue with that, but in parameter you are passing s1. What is s1? S1 is a reference of this object. S1 store the reference means memory address of this object you have created, of this object. This S1 is passed as here. Now, and the value, how the value will be initialized, let me show you in memory diagram. Till now you have created an object, pass the reference variable S1. S1 stores the memory address. Fine, no issue with that. Again, what happened here? You again create a new object student. Fine, no issue. You create a new object, let's say 2000. You are passing what new object you are creating student type. So these are the uh, instance variable. It will create as it is id, name, marks, and the default value will be initialized. Fine here, no issue. Now the constructor will be called. See, now which constructor will be called? This one or this one? So it matches the parameter. So this is a reference. This is a reference variable which stores the object address of this object. So constructor, so it it matches. It tried it matches. So it will go to the student class and check which constructor matches the same parameter. So this constructor matches the same parameter which have student s, means the reference which stores the reference of object. Now this dot id equals to s dot id, means s1 you have passed here at the time of object creation. This becomes s1 when you store s1. So this will be like this will be like you pass s1 here. So whatever s1 id, whatever is s1 id, s1 name, and s1 marks will be passed here. And this dot id, this refers to what? This refers to the current object which is running. This refers to s2. It will be like s2 dot id. It will be like s2 dot id. What is s2 dot id? s2 s2 stores the memory address 2000. s2 dot id is what? s2 dot id is this. And s1 dot id, what is s1 dot id? s1 dot id is this one only, it having the value 1. So here you write s2 dot id equals to s1 dot id. s1 dot id is 1. s1 dot id is 1. So it will store here. This become 1. I hope you are getting. I hope you are getting. This will also become s2 because this refers to the current object. This refers to the current object. This keyword refers to the current object. This become s2 dot name equals to s1 dot name. What is s2 dot name? s2 dot name is this one, and s1 dot name is what? s1 dot name is Raj only. So s1 s2 dot name equals to s1 dot name. It will become Raj. In the same way, this will initialize with 97. Now, now what happen is, so when you print the value, okay, let me change it, the original one, this here s, here s, here s, and here this, and this. I hope you understand what I'm trying to say. Now let me run it again. I hope there no error for now. Okay. let me print there. Let me print the values of S1 and S2. You can see the S2 will get the same value as S1. In memory, we have also seen how these values are getting initialized. Now, as you also see, the memory address are different. Means this is a new object. Means this is a new object. Here we create a new object, but here we create a new object by copying the values of another object. Here we create new object. Fine. How we create? By copying. We are copying the values. We are copying the values and creating new object. That is copy constructor. That is copy constructor. I hope now you can understand the definition of copy constructor. What is copy constructor? Copy constructor is a constructor. A copy constructor is a constructor. This is a constructor only that create new object by copying. That create new object. It create new object. How? By copying the values from another object of same class. So this is within the same class, student. This is within the same class, student, and this copying this this object this object is copying the value of another object. This object. Fine. Let me explain it again. So this object is copying the value of this object. Fine. That is copy constructor. Copy constructor is a constructor that creates a new object by copying the value from another object of same class. I hope now you will understood. Now, what if try to guess the output? Now, what if I'll print the memory address of S1 and S2? What will be the output? What will be the output? See, S1 and S2 both are having different memory location, as I have told you in memory diagram also. Fine, here I will also prove it that S1 and S2 have different memory location. Now, what happened in earlier case when now let me tell you one thing also. If if you want to change, let's say S1 dot name equals to, let's say, Raju. Now if we print so S1 name is changed. S1 name object, this object name is changed, but this will not affect the S2 object name. Fine. This will not affect the S2 object name. Why? Because they are stored in different memory location. So changing one value does not affect the does not affect the another value. I hope you got I hope you got it. Now let's proceed further. See, here I have also shown you by printing the memory address of S1, S2, and S3 object. This I have also already told you the memory level understanding. I have already given you the memory level understanding why constructor is needed. So in uh, this way you can also copy, in this case S2 just copying the memory address of S1. I've told you that if you create a reference variable S2 and you just pass the S1, in this case just the memory address is copying, fine. And if you do any change, let's say you make S2 dot marks 40, so then the S1 marks already also changes. The S1 marks also changes. Okay, so let's wrap up this part one. And in part two, we'll start with how to pass a class as an instance variable in another class. And some topics were left like shadow copy, deep copy, and then we will proceed to the four pillars of OOPS, that is inheritance, polymorphism, encapsulation, and abstraction. We will cover in detail and depth, and I will also provide you the notes. You can check out my description to get the notes. Okay. Till then, keep studying. Bye bye.